Okay, hi. This is Michael Ellis, and I've got a little treat for you today. Um, so my sunlight by wire experiments were a total catastrophe. So in the interest of survival, I've decided to look for, we'll continue looking for a surprise for many a well, I don't know, surprise or not surprise. Go figure. A battery charging uh, circuit that also uh, functions as a kind of maintainer or a powering circuit for LEDs arrays, because you know LEDs are like the perfect plant grow lights that we've ever created. So I've actually accomplished that in less than a week of being tasked that. So um, by myself actually, but I was led by a hunch rather to an old circuit I saw in the Navy Electronics Training Series Module 4, which is electrical conductors and wiring. And I remember like this is the circuit, okay? So it's basically a car circuit, and it has like induction coil or ignition coil, that goes to the spark plugs and all that. But it was touched on earlier in there, but I remember for some reason I don't know. I pulled up like earlier a I don't know why, for some reason it's way back there. Anyways, I pulled out a circuit like that, and it actually went over why I don't know if it was off the internet or out of this, but it went over why they use a, um, a capacitor, so you don't get sparks, and at the switch, and the ignition coil, and um, and the resistor acts. Well, maybe this was on the internet, but and the resistor to for the on position, and this must have been on the internet describing it, and the oops, and the short on the ignition. Yeah, I think it was like How Stuff Works or something. To actually the operation of it for the ignition spark. Um, but anyways, I kind of inherently suspected that it was like an Easter egg, kind of hidden in that book. This book, again, it's Navy module Electronics Training Module 4, and that goes over all the wiring techniques and stuff that are known to man. So and so so I put together this circuit. It was kind of like the result of like a bunch of different circuits I was working on. Kind of like it evolved over a couple different permutations, I guess would be the best word to put it. So basically what it is it's a battery maintainer and a LED driver. So as it works, it drains the battery a little bit, but in the end it ends up actually recharging the battery. So in its on position. So it does have the ignition coil, and that kind of acts as both the powering end of it and the recharging bit. So it actually runs off a battery, but the battery gets recharged as it runs. So you need to actually power the ignition coil and the capacitor circuit, and then you can drain all the energy off of it as you want. So or at least low demand, low voltage, not low voltage, but low demand circuits, low power circuits seem to work fine with it. I haven't tried anything adventurous off of it yet, since I'm only not using like a 12 amp hour battery on it so far. So so I need to see if I can scale it up and like actually get kilowatts or something out of it. But that might need a bigger coil or something, or whatnot. But the heart of it is the resistor from the battery, ignition coil, and the negative goes to a capacitor to your chassis ground. Positive is the from the resistor. High voltage, which I actually had to unscrew and get a wire down in there, to your load to chassis ground. And oops, sorry, my phone's ringing. Be right back. Okay, sorry, had a phone call. So the whole load goes to chassis ground, and I'm just running. I just ran overnight some LEDs, and it worked fine. Didn't drain the battery at all. And just to make sure, I have a diode running across the battery, ground to positive, and rectifying anything that's going through it to charge the battery, just like an alternator setup, in a vehicle. So yeah, and that's all there is to it, and the capacitor's there to keep the ignition coil from powering any AC type of signal down to the load. That would go straight through the capacitor to ground, and keeps it a smooth DC on your high volt signal. And it's not really a high voltage because we're not oscillating it or anything, so it's just a steady DC stream relative to the battery voltage that you're using. All this does is create a choke type of situation on the line. Who knows how it works? I think it works something like Tesla coils do, but yeah, as the kind of like a Wardenclyffe tower would work, but just so you can get the whole schematic in there if you want to take a picture of that. So that's how the circuit works. So thank you for watching. This is Michael Ellis, and feel free to go crazy with this technology. I want people to have this so they can survive coming cataclysms that everyone seems to be preparing for, especially the famine that is being engineered. I'm not going to whitewash that at all. Using this, you can grow food indoors, and that's entirely what I designed it for. I couldn't get anything near what Galen Hieronymus did without using an outdoor cell. So you might as well just use solar if you're going to do that. But this you can use batteries and run LEDs. So so thank you for following me. Thank you for subscribing, and share this like crazy everywhere. Four corners, the winds to the four corners. Make this go viral. Thanks everybody. And I did test this out, and my battery voltage was totally unchanged, still topped off after running this like all night. So and I actually had more LEDs than this, but they weren't as bright. So I suggest keeping it lower than this, because I had like 7 or 8 per set, and they weren't as bright as just running a single LED. So yeah, you might not want to have them as in parallel as in series. So so the more they're in series, the brighter they'll be. The more they're in parallel, they'll dim out a bit. That I've discovered. I don't know a lot about how LEDs work, and drivers and whatnot, but all I know is you're supposed to put a resistor for each LED so they'll live longer. But that's all I was taught about them. So yeah, have fun with this. You can power other stuff off this, I'm sure. And go crazy. Thanks. This is Michael Ellis.